A proportion is two ratios that express the same relationship. A proportion is another name for equivalent ratios. Remember that we talked about equivalent ratios in the last section. So let's begin with an example. The scale of a map is 1 inch equals 9.3 miles. How many inches will be drawn on the map to represent 390.6 miles? So what we're going to do is we're going to use this statement and create a ratio. So I know that 1 inch, and it is important that you write the units with it, 1 inch is the same as 9.3 miles. Now remember that we're doing equivalent ratios, so we're going to have two fractions set equal to each other. So one fraction is going to be 1 over 9.3. The other fraction is asking us how many inches will be drawn on a map to represent 390.6 miles. Now, the thing that you need to be careful about here is when you put the 390.6 miles in for your ratio, if miles is on the bottom of the first fraction, then miles needs to be on the bottom of the second fraction. So the 390.6 needs to go on the bottom as well. So you want to be sure that as you're looking at it that you have both of the inches on the top and both of the miles on the bottom. You need that consistency in the units. Okay, so how many inches? That is my x. So we're going to be solving for x inches. Now from there, we're going to do exactly what we did in the last presentation. We're going to cross multiply. So I might begin by saying 1 inch times 390.6 miles. So 1 times 390.6 is still going to be 390.6. And then I'm going to multiply on the other diagonal. So the x times the 9.3. And that's going to give me 9.3x. Okay, so just like we did in the last section, we're going to cross multiply. And then we're going to solve for x. So we need to get rid of this 9.3. So I'm going to divide both sides by the 9.3. That'll make it cancel here. Leave me just x. And then I'm going to go to my calculator with what's left. So 390.6 divided by 9.3 gives me 42. All right, so my answer to this one is going to be 42 inches. All right, let's try another one. A recipe for waffles calls for 4 teaspoons of baking powder to make 6 waffles. Okay, so again, let's take that first sentence and set up a ratio. So 4 teaspoons of baking powder for every 6 waffles. Now remember, the way that we have this set up, we want teaspoons on the top, waffles on the bottom. So the question is asking us how many teaspoons. So that's going to be my x. It should be on the top for the teaspoons. How many teaspoons of baking powder would be needed to make 27 waffles? So the 27 waffles, because the waffles is on the bottom, will go on the bottom of our second ratio as well. And then we work it out. So again, we're going to cross multiply. So I might start with the 4 times the 27. So 4 times 27 is 108. And then multiplying on the other side, 6 times x is going to be 6x. We need to get rid of the 6 so that the x is by itself. So we'll divide both sides by 6. The 6's will cancel, and we're going to be left with 18 is equal to x. And so we will need 18 teaspoons of baking powder to make 27 waffles. All right, let's do one more. Monique wins 5 games of chess for every 3 she loses. If she played 40 chess matches last month, how many games did she win? So let's take our first sentence and let's make a ratio. So Monique wins 5 games of chess. So she has 5 wins for every 3 games that she loses. If she played 40 chess matches last month, how many games did she win? All right, so we are looking for how many games did she win, so that's going to be my x. And then we run into a problem. We're told that she played 40 chess matches. If we put the 40 plays or the 40 games that she played down here, then we don't have consistency with our variables. We have the wins on the top, but the bottom doesn't match. We have losses, and then we have the games. So we've got to adjust one of these two. So what if we come back to this first ratio? Do we know how many games she plays? If she wins 5 and loses 3, how many games did she play? She wins 5 and loses 3. She's going to have played 8 games, right? There are 5 wins and 3 losses, so she played 8 games. So that's going to work a little better. Now we have the total number of games on the bottom, and we have the wins on the top. All right, so now let's cross multiply. So 5 times 40 is going to give me 200. 8 times x is going to give me 8x. We're going to divide both sides by 8. And that tells me that there are 25 wins. All right, our last problem says Gary studies 6 hours a week for math class. Ray studies 1.5 hours for every hour that Gary studies. How many hours a week does Ray study for math class? So again, this one is a little bit more difficult because our pieces are arranged in a slightly different order. So I'm going to take this sentence, which is going to give me a complete ratio. So we know that Ray studies 1.5 hours. For every hour, so that's a 1 hour that Gary studies. So Ray studies 1.5 hours for every 1 hour that Gary studies. Now the question is asking me, how many hours a week does Ray study for math class? So I'm going to have up here the x, because on the top we have Ray. So Ray studies how many hours? And what about the time that Gary studies a week for math class? They told me in the first sentence, Gary studies 6 hours a week for math class. All right, so we're going to put that on the bottom, 6 hours for Gary. All right, and we'll do a quick check. We have both of the variables, both of the numbers that relate to Ray as the numerator of the fraction, and both of the numbers that relate to Gary in the bottom part of the fraction. So we'll go ahead and we'll cross multiply. So 1.5 times 6 is going to give me 9. And x times 1 is just going to be x. And so how many hours does Ray study for math class? Ray studies 9 hours.